Hiya, so in this video we're going to be going through something called a logic gate, okay? Inside the computer, you know there should be loads of zeros and ones, and it's these logic gates that make decisions. Now, actually these logic gates allow us to do binary maths and make decisions and make things in a game work when we want them to. It allows the computer to ask questions and then do a response based on those questions. In this unit you only need to learn three gates: and, or, and not. They're the only ones that will come up in the exam. And to explain how these gates work, I'm going to demonstrate them here with this simple system. So an AND gate takes two inputs and has one output. So here I have a very simple, just look at this top bit here, a very simple circuit with two switches, white being off, so hence 0, and red being on. You can see it goes green when it's red. And this AND gate will only trigger an output if both input A and input B are on, or if both the inputs are on. You don't have to be called label A and B, but most people do. So I turn on A, no output, turn on B, no output, but when I turn off A and B, you can see that it's an output and the propeller spins. So that's called an AND gate. Okay, so I'm going to bring in this. So if you look here, this is the actual symbol for an AND gate. On this system here it's got a box with AND in it, but actually it looks like this. And this is a truth table. And what a truth table is, it's every single possibility of these switches. So you've got both of them off, you've got A off, B off, A off, B on, you've got A on, B off, and A on, B on. So basically it's all of the options that you can have of these four switches, because there are two switches, because there are four options with two switches. And then you've got the output. As you can see here, this is on 0, 0 and no output. See if I move that there. I'll just shrink this a little bit. Move that back. So now you should be able to see this. Yeah, you see enough of it. So if I put A on, A is 1, B is 0, no output. If I put B on, A is 0, B is 1, no output. However, if I put 1 on 1, it's an output. So that's what an AND gate does. What's next? An OR gate. They're quite well named gates, so you should probably be able to work out what an OR gate does. That is A or B. The only slightly confusing thing is whether it works when it's both are on, and it does. So an OR gate works, let's connect it up first so it won't do anything, if either switch A or B is on, or both. Okay? So it can be A or B or both. And if you see here from this truth table, the only time when the OR gate stops working is when both of them are off. Now you might start thinking, what is this? Why would you use all this? Well, in digital electronics, imagine a game or a system, let's do a system, where you've got to have two switches turned on to, say, launch a missile. It's a system to protect accidental launching. And you might think, oh, that's a bit far-fetched. Well, let's talk about a car. My car will only start the engine if I'm in park and I have my foot on the brake when I press the button. So actually there's three things I need to have. I need to have it in park, foot on the brake, and another one. And if I wanted to do that using AND gates, I can connect 2 or 3 together, and I'll show you that in a bit. And modern computers, modern cars are controlled by computers. So this is exactly the sort of system that would have inside. It's in the circuitry somewhere, making decisions. Okay, and all one simple, a burglar alarm system. If any of the alarms gets triggered, then the alarm goes off. So you can quite easily see where that would be the case. Last but not least, a very useful, much simpler gate. This one simply flips it. So as I connect this, you'll see that it will go on instantly because it is not turned on. And a NOT gate simply flips a 0 to a 1, or inverts it, as people say. So it takes a 1 to a 0, 0 to a 1. This could be the case, for example, like in my car. I can't start the car with the door open. So it would check that the door is not open. So if the sensor triggering that the door is open is not on, it will allow the car to start. You can see various instances where you might need to flip a result to have the opposite. So as I said before, Okay, these are all the options. Obviously with NOT gate, it only takes one input and one output, but you can use these consecutively. And that means in one after the other. So let's say I want to do a system that had 3 switches, all of which had to be on. Well, if I put, so that's A and B and C. Well, you might think, well, I'll just get another A. I'll just get another AND gate. So it's A and B and, oh, hold on, I can't connect these together. Well, what you would simply do here is, you would connect them up like this. There we go. Now all 3 have to be on. Because think about it. If A and B are on, then this will trigger this output into this AND gate. And if this was on, it'll trigger the output there. If I needed B to not be on, so that had to be off, and A and C on, I can simply put a NOT gate. I think I can then connect those up. Just do that again in case it didn't work. Right, there we go. So now A and not B have to be on. That will trigger that, and then and C. So you can see that you can use these in combination. Okay. So hopefully you have a brief understanding of what the simple logic gates do. The words give them away. So if it's an AND gate, A and B. If it's an OR gate, it's A or B. And if it's a NOT gate, it flips it. You need to remember the symbols, which look like this. I suppose that's a little bit more tricky to remember the symbols. I'll zoom out a little bit. That's probably a bit too much. But unfortunately, it's not. There's not much in between. And you just have to remember those. So what I want you to do is, in the book, I want you to, without looking at the videos, you need to write out the truth tables. Now, the problem is with these truth tables, and I do go through doing truth tables more with the Boolean expressions, is this bit here. You just have to remember that the right column goes 0, 1, 0, 1, and the left column goes 0, 0, 1, 1. And then you just go, is it A and B? No. Is it A and B? No. Is it A and B? No. Is it A and B? Yes. So just remember, if you want to know how it's actually done, this is the binary number for 0. This is the binary number for 1. And this is 2. And this is 3. So they are all the options you can have. Just like if you only had 2, if you just had like 1 and 2 here of a binary number, you know, you haven't got 4, 8, 16. No, this would go 4, 8, 16. But we haven't got those because we've only got 2. So A essentially is that one, and B is that one. And then you can quite easily see what the numbers should be. Okay? So that's how you do it. So have a go at the worksheet, and I'll go through the answers with you when you speak to me.